Okay, we continue discussion. Okay, continue discussion on our course SMS 2310 mathematical analysis. Okay, so now we come to the second part of our course, and I will continue from Dr. Pa's lecture. And previously you already discussed and already consider some concept of definition of partial derivatives, and you already consider examples, and then you come to the application of partial derivatives. Okay, so this one you already discussed with Dr. Pa, and then come to the second part. Where second part, I will be the instructor. Okay, I will be we will consider this second part with me, and in this second part we will discuss about multiple integral. Okay, multiple integral. Okay. And before we go to the our main topic, multiple integral. Okay, so since this is just this is the first class, okay, and so let's start with some preliminary. Okay, preliminary. Okay, before this. Okay, I think that you already discussed with Dr. Pa something that we call it as a closed region. Okay, closed region. Okay, closed region. Okay. Okay, of course, we can consider a closed region here in 2-dimensional, 3-dimensional. Okay, but it's very easy for us to discuss closed region in 2-dimensional. Okay. So actually, if we can understand what the meaning of closed region in 2-dimensional, then it's very easy for us to just extend a closed region in 3-dimensional. Okay, actually, they just share the same thing. Okay, just the definition is same about closed region, but the difference here, how we can describe this closed region in 2-dimensional, in 3-dimensional. Okay. Okay. So therefore, in this preliminary, I would like to start with what the meaning of closed region in 2-dimensional. Okay, because it's very important. Okay, it's very important for you to know. Okay, this closed region in 2-dimensional, and also after that we will come to the closed region in 3-dimensional. Okay, but of course I would like to start with closed region in 2-dimensional, since it's very easy for us to see and then try to understand. Okay, what actually we want to have in this closed region in 2-dimensional. Okay, and then the other things, why is a closed region in 2-dimensional here is very important. Okay. 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 First, let's start. What do you mean of closed region in 2-dimensional here? Okay. So. Okay, in 2-dimensional here we can just consider a region in the xy plane. Okay, a region in the xy plane. So we have yx. Okay, so we can consider 2-dimensional here in this region. Okay, in the xy plane here. Okay, why? Because what do you mean of 2-dimensional? 2-dimensional here meaning that we have the collection of, okay, so this is the meaning of, okay, so we have a real number, power of 2. So this is the meaning of two-dimensional. Okay, so what the meaning of two-dimensional here? Okay, two-dimensional here is just a collection. It's just a collection of xy here. Okay, collection of xy, collection of point. Okay, where of course my x and y here is just a real number. Okay, so we have this one. Okay, so this is the meaning of two-dimensional. Okay, so we have a point xy where x here is a real number and y here is any real number. Okay, of course x and y here is independent. Okay, independent. So this one already discussed by Dr. Pah, what the meaning of independent variables. Okay, if you have two variables here that independent, or three variables that independent, so this is the meaning of, so this is just a point. Okay, all collection of all point. Okay, where x can be any real numbers and y can be any real numbers. Okay, so this is the meaning of two-dimensional. Okay, so therefore for two-dimensional, okay, we can just consider, we can just see a region in the xy plane. Okay, we consider the whole thing here. Okay, so therefore we consider the whole thing in the xy plane. So this one will be R2. Okay. Okay, so now we would like to discuss I would like to check my battery. Okay, so okay, so okay, already charged my handphone here. Okay, okay, so now let's consider a closed region in two-dimensional. Okay, so let be this one is my closed region in two-dimensional. Okay, so I will denote okay, closed region. So I will have shaded region here. Okay, so let's consider a closed region in two-dimensional. Okay, let me denote this one as R. Okay, R. Okay, so I will have a different R. Okay, this is R, and then this one is R, the set of real numbers. Okay. Okay, now we'll consider a closed region R in two-dimensional. Okay. Okay, first of all, what the meaning of closed region? Okay, closed region here meaning that you have some region. Okay, you have a some region R here. Okay, and this region R is bounded by a closed curve. Okay, it's bounded by closed curve. Okay, so we have a closed curve. Of course, this closed curve, the outside part. Okay, the outside part. This one we call it as a closed curve. Okay, closed curve. So such of region that bounded by closed curve. Okay, outside here. Okay, so therefore we call it our R here as a closed region. Okay, closed region. Why we call it as a closed? Because our R, okay, our region has a boundary. Okay, has a closed boundary. Okay, or I can say that my R, my region R has a closed curve region. Sorry, not closed curve region. Closed curve boundary. Okay, so we have a closed curve boundary. So this one is a closed curve. Okay, we have a closed curve boundary. Okay, so therefore we call it our R here is closed. Okay, closed region in two-dimensional. Okay, so I will not discuss more detail about what the meaning of closed curve. Okay, so I think this one already discussed in analytic geometry course. Okay, so if you forgot what the meaning of closed curve, you need to recall back in this course. Okay. Okay, so now now we have that a closed region in two-dimensional. Okay, so therefore we have a closed region R. Then I can say that my R here is a subset of R2. Okay, so I can say that my R here is a subset of 2. Of course, R here is subset of R2, meaning that meaning that R here is somewhere in the R2. Okay, somewhere in R2. Okay. Okay, so now what we want to do today in our preliminary, okay, so we want to describe, okay, from this R, closed region R, okay, we want to describe, okay, we want to describe all points, okay, all points. Okay, let me this one, all points. Okay, all points. Okay, of course, because since R subset of R2 here, two-dimensional, all points x, y in, okay, by R. Okay, in my R. Okay, so today we want to describe. Okay, we want to discuss how we can describe all points x, y in closed region R. Okay. Okay. Okay, when we consider all points, okay, we will consider all points x, y in R, okay, closed region R, meaning that we want to describe meaning that when we consider all points x, y in R here, these points cover all interior and also boundary points in R. Okay, so this concept of interior and boundary points was also already discussed by Dr. Park, okay, in previous part. Okay, so I will not repeat again what the meaning of interior and also boundary points. And I hope that you still remember the difference between interior and also boundary points. If you forgot, then you need to recall back. Okay. So I just want to, okay, it's start. Okay, describe. Okay, so so we want to describe, meaning that we want to okay, we want to, when we consider all points x, y in R, like I said before, we will consider all interior and also boundary points. Okay, but the first the thing that we want to describe here, meaning that we are not talking about which point is the interior and which point is boundary. Okay, describe here meaning that we just want to collect. Okay, we just want to collect all interior and boundary points here. Okay, and then we just want meaning that we just want to collect all these points and then just put into some collection. Okay, some set. Okay, so today we want to discuss this one. Okay. Okay, so now the idea. Okay, the idea how we can describe all points in R. Okay, where R here is a closed region in two-dimensional. Okay. Okay. Of course, since my R here is a subset, okay, of this two-dimensional. Okay. Okay, so maybe I can just describe. So I can say that my R, okay, my R here is of course, okay, my R here should be collection of all point x, y, okay, from R2, okay, R2 here lah, okay. So because since our R is a subset, okay, our R is a subset of R2, so therefore I can say my R here is a collection of all these points, Okay, all point here is that taken from R2. Okay. Of course, when you see the closed region R here, okay, what can I say? Okay, closed region of R here, we are not talking about taking the all point. Okay, taking the all point from R2 here. Why? If we consider all point from R2 here, it doesn't mean that we discuss about this R. Okay, always remember when we consider all point from R2. Of course, when we consider all point from R2, so we will have the whole thing. Okay, we will have the whole thing here. Okay, we will have the whole thing. Okay, so it will cover the whole thing. Then we will have something that called unbounded. Okay, unbounded region. Okay, unbounded region. Okay, it will cover the whole thing here. So when it cover the whole thing here, meaning we have the two-dimensional. Okay, so therefore, when we want to describe this R, closed region R, meaning that this X and this Y here should have some condition. Okay, X and Y should have some condition. Therefore, when we have this condition for X and Y, meaning that we actually discuss, okay, or describe all points in our closed region R here. Okay, always remember that. Okay, because of course my R here, when I consider this point from R2, so X here cannot be from minus infinity to infinity. Okay, same with this Y, cannot be from minus infinity to infinity. Okay, like I said before, if I consider my X here from infinity, negative infinity to infinity, and also Y here from negative infinity to infinity, so meaning that I will cover the whole thing in this two-dimensional. Okay, but now since my R here is just a sum part, okay, of my R2, so therefore my X here have a sum condition, and my Y here also have some condition. Okay. Okay, so now let's discuss, okay, how to find the condition of my X and condition of my Y here. Okay. Okay. So now, okay, let's start first. Okay, let's start first. How to find the condition for my X? Okay, for my X. Okay. Okay, so you see, since our R, okay, our R, okay, so we have our R here is depend the value of my X and also depend the value of my Y. Okay, and of course X and Y here is dependent. Okay, you see, when we look our R here along X axis, okay, let's start. Okay, let's start first by looking my R along X axis. Okay, it seems that my R, okay, is in between two values of X. Okay, it's between two values of X. Okay, what are these values of X here? Okay, when I say that my R is in between these two values of X. Okay, the first values of X will be the minimum. Okay, the minimum value. Okay, maybe the minimum value is somewhere here. Okay, minimum value here is somewhere here. Okay, and then the second value will be the maximum value. Okay, the maximum value. Okay, somewhere here. Okay, so now I can say that my R here, okay, my closed region R here is in between these two values of X. Okay, these two values of X. If I have this, okay, let be this one, X equals to A and X is equals to B. Okay, of course X equals to A here, I can say that the minimum value. Okay, the minimum value for my R, and also X equals to B is the maximum values of X in R. Okay, okay, so you see, now we can see that, okay, or we can find that actually my r here is between of these two values of x. Okay, these two values of x, where x equals to a here is the minimum value. Okay, the minimum values of x in R, and x equals to b is the maximum value of x in R. Okay, so therefore from here, okay, the first condition I can say that my x here, okay, the value of x is in between a and b. Okay, a and b. Okay, of course a here will be the minimum. Okay, the minimum value of x in R, and b will be the maximum value of x in R. Okay, of course the first condition here, when we're talking about the value of x in R, okay, it should be between the value of a and b. Okay. Okay, of course this value x equals to a and x equals to b here. Okay, I can say that x equals to a here, it will intersect to one point. Okay, one point at the boundary of R. Okay, some one point at the boundary of R, and of course same with this one when we consider x equals to b, meaning that when x equals to b here, so supposedly they will intersect. Okay, they will intersect. Okay, what the meaning of x equals to b? X equals to b actually this straight line, right? Okay, this straight line. X equals to a is this straight line, so it will intersect. Okay, x equals to b, it will intersect one point, okay, at the boundary of R. Okay, so this one. Okay, let for example, if I consider x equals to a, okay, it will intersect to one point at the boundary of R, and x equals to b, it will intersect one line here, it will intersect to one point here, okay, at the boundary of R. Okay. Okay, so now after we find the condition of x, okay, so next thing we need to find the condition of my y. Okay, we need to find the condition of my y. Okay, so now how I can find the condition for values of y here? Okay, since my y here is taken from so my y here in the R, okay, closed region R. Okay, okay, you see. Okay, so now the problem here, we want to find the condition of my y. Okay, so you see, seems that you have something like a point x equals to a, and also a point x equals to b, where a point here, okay, 2 points here is the intersection. Okay, so point here, sorry, it's not intersection. Okay, this point at the boundary of R. Okay, x equals to a and x equals to b. So we have some point here, and then you see what I can say about these 2 points. Okay, so this, from these 2 points, actually I can say that these 2 points actually intersection between 2 curves. Okay, intersection between 2 curves. Okay, which curves? Okay, intersection between 2 curves. Okay, intersection between 2 curves. Which curve? Okay, the first curve will be the upper here. Okay, the upper. Okay, so meaning that, okay, so I can just extend. Okay, okay, so I can just extend here, for example here. Okay, and then the second curve will be the below part. Okay, the below part. Okay, this point x equals to a, x equals to b, we can see this x equals to a is equals to b actually intersection points. Okay, intersection points between two curves. Okay, the upper curves and also the below curves. Okay, so if I let the upper curves, okay, if I let the below curves, okay, if I let the below curves here, let be y. Okay, of course, such of curves here should be a function depend on x. So let be y is equals to f1x. Okay, so now I have the below part. Okay, below curve here is some function with depend on x, that be f1x, and then the upper part here. Okay, now I will let my y here is equals to f2x. Okay, so supposedly we have these two curve. Okay, two curve. When we consider the intersection between these two curve, it will give us the value of this point. Okay, x equals to a and x equals to b. Okay, of course, from here, when we have these two curves, okay, so now it's clearly, okay, we can see clearly my y here is between f1x and also f2x. Okay, why? Because of course my y here should be taken from when we consider the values here in between, meaning that this value should be the less, and then this one should be the more part. Okay, this one should be the smaller value, and this one should be the larger value. So of course it will start from f1x. My y here should be in between f1x and then until f2x. Okay, so therefore this is how we can describe. Okay, this is how we can describe all point. Okay, this is how we can describe all point in R. Okay, so meaning that when we want to describe all point in R, always remember, actually we want to collect, okay, all point xy from R2. Of course, we are when we want to describe all point in R, meaning that we want to select, okay, we want to collect some xy from R2. Of course, we are not talking about all xy. Why? Because when we're talking about all xy, meaning that we're talking about the whole thing, okay, two-dimensional. Okay, but now we want to only describe all point in R. So meaning that we will collect some point in R2 with some condition of x and some condition of y here. Okay, so how we can find the condition of my x? We can find the condition of my x here by looking the minimum value. Okay, my R here, it should be between two values of x. Okay, how to find the two values of x here? Meaning that we need to find the minimum value of my the minimum value of x and also the maximum value of x. Okay, of course we will have x here is between a and b, and then after that, after we find the condition of my x, then we need to find the condition of my y. Okay, because of what? Because we already know that my x and y here is independent. Okay, so now how to find the condition of my y here? So by looking the two curves. Okay, by looking the two curves, the below curves and also the upper curves here. Okay, the bottom and also the below part of the below curves. Okay, sorry, below curves and also upper curves here, where these two curves, when they intersect, it will give the point x equals to a and also x equals to b. Okay, after you find these two curves, always okay, when you find these two curves, meaning that my y here should be in between the smallest value, okay, and then this one will be the greater value. Okay, of course this smallest value here will correspond to the below curve, and then the largest value here correspond to the largest curve. Okay, so this one largest value. Okay, largest value. Okay, this one is the smallest value of. Okay, so this is how we can describe, okay, all point in R. Okay, or you can describe this R, okay, by another way. Okay, by another way. What the meaning of by another way here? Meaning that, okay, for example, the first part here, okay, the first first our discussion here, I show you, okay, so how we can describe R here by taking some part of some points in R2 with this condition. Okay, with this condition. This condition, I show you that first I'm looking the value of my X. Okay, and then I find the value of my the condition of my Y. The condition of my Y. Okay, so next, okay, in other way, we can describe my R here, okay, by looking at the value of my Y. Okay, sorry. Let be this one, X equals to A, B, and then my Y here is in between F1X and then F2X. Okay, or I can describe my closed region R. Okay, my closed region R. Okay, so what's the difference? Okay, now the second part here. Okay, I will describe my R here by looking the value of my Y first. Okay, by looking the value of my Y here. Okay, so now let's start from here. Okay, the value of my Y. Okay, so meaning that, okay, we will use the same idea from the first part here. Okay, from the first discussion here. Okay, of course, you see, when we describe in the first here, okay, we look at the value of X, where the X is between these two numbers. Okay, of course, this A is the minimum, and then B here is the maximum, the value of X. When you consider the second part here, okay, the second way how we can describe R, okay, cross region R here. Now we will try to we can describe my R here by looking the value of my Y first. Okay, of course, the value of Y, meaning that we need to see from this part. Okay, we need to see from this one. Okay, we need to see from, okay, along this one. Okay, so meaning that you see my R here is in between these two values of my Y. Okay, these two values of my Y here. Okay, so of course we can see that our R, okay, our R here is between two values of my Y, where this part, okay, this part, let be Y is equals to C, and let be this one Y equals to D, meaning that Y equals to C here will be the minimum value. Okay, the minimum value of my R, and also Y equals to D here will be the maximum value of my the maximum value in R. So therefore from here I can say that my Y here is between C and D. Okay, Y here is between C and D. Okay, so it's just the same thing like the first part. Okay, but now the difference here, when I consider the first part here, meaning that I will see first my R here from the x-axis, okay, along x-axis, meaning that my R here should be in between these two values, A and B, along x-axis. Now the second part, I'll show you that how I can describe my R, okay, by looking my R here along y-axis. Okay, sorry, I forgot about this this term, okay, this explanation. So first I will see my R here along y-axis. When I see my R here along y-axis, it seems that my R here is between these two values of y. Okay, these two values of y, where x here is equals to c, and so from the smallest value is y equals to c, and the largest value is y equals to d. Therefore, I will have y here in between c and d. Okay, so it is the first one. Okay, so the first condition of my y we already found, but now we want to find the condition of my x. Okay, how we can find the condition of my x here? Okay, still same idea. Okay, you see c here. Okay, if I consider c, okay, so this value, I can say that this value is actually 1 point. Okay, 1 point in the boundary. Okay, 1 point in the boundary. Of course, y equals to d here also is a 1 point in the boundary. Okay, 1 point in the boundary. Okay, and then we can see this boundary, this point C and D actually is the intersection between two curves. Okay, intersection between two curves. Okay, which curves? The first curve will be the left part. Okay, the first curve will be the left part here. And then the second curve will be the right part. Okay, the right part. Okay, for example, if I have this one, okay, if I extend the curve here, maybe we have this one. Okay, so we will have the intersection between two curves, the left part and also the right part here. Okay. Of course, you need to see the curve here along x-axis. Why? Because we already see our R here along y-axis at first. Then now we need to see our two curves here is along x-axis. Okay, meaning that, okay, if we see that our curves here along x-axis, for example, if I consider the left part of my curve, now I will have x here is equals to some function depend on y. Okay, x equals to g1y, and then the second curve here, since my second curve here also I see from the x-axis, so I can let, okay, so from here I can just let my x here equals to some function depend on y. Okay, let me g2y. Okay, so this one. Of course, now what the condition of my x here? What the condition of my x? Okay, so since the g1y here is the smallest value and g2y here is the largest value, so you see my x here should be from g1y to g2y. So now I will have my x here between g1y and also g2y. Okay, so this one. Okay. Okay, so this is how we can describe, okay, all points in R. Okay, we can use two ways here. Okay, we can use two approach how we can describe all points in R. Okay, the first approach here, meaning that you find the condition for the x first. Okay, of course, x should be in between these two values. Okay, and then you find the condition for y, where the y here you need to find two curves. Okay, two curves. Of course, when I consider two curves here, meaning that we need to find two function. Okay, two function where this function here should be depend on x. Okay, should be depend on x. Okay, of course, when you find these two function here, meaning that these two functions should have a condition that when you take the intersection between these two functions, or I can say that intersection between these two curves, it will give the values of A and B. Okay, you need to find this one. Okay, you need to find such of two curves here. Okay, Of course, to find such of two curves here, the condition here, when you take the intersection, you will have the values of A and B. Okay. Or in the second approach, okay, you can describe all points in R here. Okay, from this second approach, you can describe all points in R here by looking the values of Y. Okay, the values of Y first. Okay, of course, when you consider when you see when you want to find the value of Y here, meaning that you need to see your R here along Y axis. Okay, along Y axis. Okay, and then you see that my Y here is between the values of C and D. Okay, C and D, meaning that C here is the minimum value of my Y, and D here is the maximum value of Y. And then after that, along x-axis here, and you can see when you see the R here along x-axis, you will see that x here is between these two curves. Okay, between two curves. So that be the first curve G1y, and then the second curve G2y. Okay, of course, this curve should be depend on Y. Okay, a function depend on Y. Why? Because you see your R is along x-axis. Okay, so of course this x here should be in between the smallest value and then the largest value here. Okay, so we have G1y and G2y. Okay, so this is how you can describe all points in R, okay, by these two approach. Okay, because of that we have OR here. Okay, OR meaning OR here meaning that you can choose either one. Okay, you can choose the first one or you can choose the second approach. Okay. Okay, some remarks. Okay, some remarks. Okay, always remember when you want to describe the R here. Okay, when you want to describe the R here, meaning that you need to find the condition of your X and Y. Okay, X and Y. Same with this one. X and Y here, right? Okay, but now the difference here. Which values you want to see first? Okay, which value you want to find the condition first? Okay, for example, the first approach here, you find the condition for the X first. Okay, for the second approach here, you find this the condition for the Y. Okay, okay. Always remember some remarks. Okay, when you want to find the condition for X and Y here, always remember the first condition here should be the values. Okay, you need to find the values A and B. Okay, the values. And then the second condition here, you need to find the function. Okay, you need to find the function where the function here when the function here intersect will give the value of A and B. In other words, please remember, when you find the first part is already understand. You need to find between this value A and B, right? Okay, always remember when you want to find the Y here, don't find Y here between two values. Okay, meaning that for example, in my experience, I see that some students make a mistake when they find X in between two numbers, and Y also they found that this Y also between two numbers. Okay, for example, we consider that, okay, this is just a common mistake that makes by student, meaning that after they find X here between these two numbers, then they say that also Y here is between these two numbers. For example, C and D. Okay, C and D here. C and D. Okay, they do like this one. Okay, C and D. Okay, they have some values C and D. Okay, of course this one is wrong. Okay, this one is not correct. Why? Okay, of course when you consider, okay, for example, X here in between A and B. Okay, what do you mean between A and B? Between A and B meaning that, okay, it's between these two numbers. Okay, between these two numbers. And then when you consider Y here between C and D, okay, C here is value, D here is value. Okay, what is the value? Okay, the value somewhere here. For example, the value of C is this one. the value of C is this one, and then the value of D is this one. Okay. Of course, if you consider search of X here between A and B, C here between Y and D. Okay, what the meaning of this one? Meaning that, okay, when I consider X here between A and B, the first will be this part. Okay. Okay, meaning that X here in between this value, right? A and B. Okay, when you consider my Y here between C and D, what the meaning of Y between C and D? Y between C and D will be this part, kan? Meaning that we will have this part. Okay, because your Y here between C and D, C and D, meaning that you consider the whole part here. Okay, the whole part X over here. Okay, so you see, when you describe this one, this condition, actually it will not give you R. Okay, it will not give you a closed region R here, but it will give you the whole rectangle. Okay, it will give you the whole rectangle here. Therefore, the rectangle here is not our R. Because of what? R here, we will have a closed region here, right? Okay, closed region here. Okay, but this description here actually discuss about the rectangle. Okay, about the rectangle, closed rectangle. Okay, so therefore, if you describe by this condition, it's wrong. Okay, it's not correct for your R, because this one is correspond to rectangle. Of course, we are not consider the closed rectangle here. We just want to describe, and we want to discuss of closed region R. Okay, okay, always remember that. Okay, so how we can describe our all point closed region in R. Okay, so you can describe by two approach. Okay, you can describe by two ways, where first approach you can see the value of X first, and then you find the curve between the two curves, where Y here between these two curves. And then the second approach, where you see the Y first, okay, along Y axis, and then you try to find the two curves, okay, along X axis, where the intersection between these two curves will give you the value of Y. Okay, minimum and maximum of Y. Okay, always remember, don't describe the point, okay, all point by this condition. Okay, meaning that you have X here between two values, and also Y here between two values. Okay, of course, when you consider X here between two values and Y here between two values, actually you are not discuss this R. Okay, all point in R, but you already now discuss all point in this rectangle. Okay, so this one. Okay, so this is just a, one can say this is just a common mistake that did by students previously. Okay, when they want to discuss all points in this closed region, they describe by this condition. Of course, this condition is wrong. Okay, because this condition, when you consider all point in rectangle. Okay, okay. So this is just an idea how you can describe all point in the closed region in two-dimensional. Okay, of course, after this, when we consider a closed region in three-dimensional, so in three-dimensional they just share the same thing here. Okay, but of course, to try to understand the simple one, okay, let's start with the closed region in two-dimensional. Okay, so let's consider example.